This is a tutorial for the mass spectrometry simulation on my website here. And when you open it up, there's a gun that you can use to fire charges. And this is the magnetic field that it goes into. You can actually move it around and change its size. And if you hit reset in the bottom right corner, it goes back to there. As usual, you can control how fast or slow the simulation runs. And regarding the charges that you're firing, you can change their speeds to make them faster or slower. You can change their masses as well, heavier versus lighter. Let's speed them back up. And you can also change the charge. So here now the charge is 5 versus 1, for example. And you can make the charges negative as well if you want to shoot -3 charges into the magnetic field. If you want to, you can move the gun right into the magnetic field so you get full circles. The speed and mass and charge, these are all kind of normalized to be easy numbers. They are not meant to represent meters per second, grams, or elementary charge units. The magnetic field, this is B. You can vary the strength of the magnetic field up to, I guess, 1 and down to -1. And you can see the charge is making kind of funny circles right now. I'll just reset the whole thing. And let's see what else. Let's add a B back. You can add vectors to the charges if you want. If you want to see their velocity and force vectors, maybe that's a little bit too strong, isn't it? Let's weaken the magnetic field here. So you can see the force and velocity vectors. You can add trails, which can be kind of a nice touch if you want to add little trails. Let's get rid of the vectors there. Little trails for them so you can see the full circle. Random mass gives everything the same speed, which is 10, but actually fires out particles of different masses, just so you can see how they're differentially affected by that magnetic field. I also have a capacitor here at the bottom, and you can move it around. You can also change its length if you want, and you can kind of snap them towards it. Now, right now, there is no electric field in the capacitor, but if you want to, you can give it an electric field and see how that impacts. Perhaps we'll give it a negative electric field here to make them curve upwards. And you can try and balance the electric field with the magnetic field. So maybe we'll give it like a -1. We'll see if that does it. That's pretty good. But you don't have to guess and check and try and figure it out because I have a button on my... Oh, there you go. That's perfect. I have a button that says match BE, which means match the electric force to the magnetic force. So for whatever charge or whatever you give them, if you just click match BE, it will just automatically give you the right electric field in the capacitor, so they pass straight through if you're solving one of those problems. There's a couple of different modes as well. If you click on C14 mode, if you just click on this little toggle at the top, this is carbon 14 mode, and it's meant to just demonstrate that the odd carbon 14 atom will make a larger circle than most of the carbon 12s. These are not the real proportions either, but it gives the kids an idea of how you can separate charges of the same charge but different masses. The final mode is a velocity selector, and it's a velocity selector if you want to talk about that. So, of course, these are charges with the same mass and charge but different speeds, and it will select for only those velocities that you're looking for. And those are all the ways that I use the simulation. I hope you find it useful.